All right, so we've talked about volume of prisms, right, and cylinders. So now we're in the pre-algebra 10.8 video. We're talking about volumes of pyramids and cones, right? So time to get our Egypt on. So speaking of Egypt, just a quick history lesson. Of course, the pyramids are in Egypt, but did you know there's I think it's like 138 pyramids that have been discovered. Most of them are around Cairo, okay, up there. And of course, in Egypt you have mass transportation via camel. All right, so let's talk about volume of a pyramid. Okay, so volume of a pyramid is really, really cool. And here's why. If we had a cube, okay, and the base of this cube, we're just going to call it B for right now, and the height is H. Okay. Now, if we had a pyramid, okay, that looked like this, and yes, I know, I'm drawing it upside down, okay. You had a pyramid, and the base of that pyramid were also B, okay, and the height of that pyramid were the same height as this cube. So the area of the base there is the same area of the base there. The height of that cube is the same height of the pyramid. Okay. Let's say this pyramid was full of sand. Okay. If you took this sand and you dumped it into this cube, here's what you would have. You'd have a cube whose volume now is made up of 1/3 of that yellow sand. But then if you take another pyramid, okay, exact same size and everything. Oh goodness, that's terrible. Okay, and this one has black sand in it, and you take that black sand, you dump it in there, you're now going to have a cube whose volume is now 2/3 made up of sand. Okay, and then if you took one more pyramid, and it's full of blue sand, and you take that, and it's the same size as this one, the same size as that one. I know they don't look quite the same, but we're pretending they're all exactly the same. And you take this blue sand and you dump it in there, you're now going to have a cube who's completely full. So what does that tell us about the volume of a pyramid? Well, it tells us about that the volume of a pyramid is 1/3 the volume of a cube that has the same base and same height. Okay? So what we do for volume of a pyramid, we say that we take the area of the base, so that'd be that right there, times the height, which was that right there, and we take that all times 1/3. So we say it's 1/3 times the base times the height, okay? So it's like saying, oh, the area of, the volume of a cube, but times 1/3. You could also, if you wanted to, you could also say it's like saying base times height divided by 3. So either one of those will get you to the volume of a pyramid. All right, so the base of a pyramid is a square. The side length of that square is going to be 24 feet. And then we're going to have the height of that pyramid being 9 feet. So what is the volume of that pyramid? Well, okay, let's think. How do we find volume of a pyramid? Remember, we said that's 1/3 times the area of the base times the height, right? Okay, so 1/3, we know that part. What's the area of the base? Well, it says that the base of the pyramid is a square, right? So if we were to draw this pyramid, it would look like this, right? And then each side of that square base is going to be 24 feet. So the area of the base would be, well, 24 times, that's also going to be 24 because it's a square, right? So 24 times 24 is going to get you 576, right? So the area of the base, I'll do this in blue, that becomes 576. But we're also multiplying that by the height. So they say the height of the pyramid is 9 feet. But what do I mean by height? Okay. Well, remember we had slant height, which was if you were to start here at this part of the pyramid and climb all the way to the top, right? The outer height is the slant height. But we're talking about just the regular height, which is from the vertex down to the middle of the bottom of that square. That's kind of hard to see there. I'll do it in red. Okay, the height we're talking about is from the point down to to the very middle of the base. Okay, so that right there. And they say that height is 9 feet. So we're going to put in a 9 feet. So we have 1/3, 1/3. Base was 576. Height was 9. Right? So now we can just do 1/3 times 576. Okay, that would get you 192. So that's 192 still times 9, and 192 times 9 is going to get you 1,728. Now again, we're talking about volume, and we're talking about feet. So it's going to be feet cubed. And that is the volume of that pyramid. All right, so let's talk about the volume of a cone. All right, volume of a cone is pretty similar to a cylinder in that the volume of a cone is equal to 1/3. Okay, so there's the similarity it has, okay? But it's 1/3 times, well, pi. Okay, so there's a difference between that and the pyramid. And it's pi r squared h. So really what that translates to is 1/3 times pi times the radius squared times the height. Okay? And when we mean radius, of course, we mean half the diameter of the circle, okay, that forms the base. And the height, we mean the height to the vertex, right? So it's not the slant height, it is the height from the vertex here to the middle of that circle, which is our base. So what do we see here, though? There's something that should kind of look familiar about this formula. We said, yeah, the 1/3, we saw that in the pyramid. But what is pi r squared? What is that part right there? What is pi r squared used for? Well, we know that's like saying, instead of saying pi r squared, we could say the area of the base, right? A-R-E-A. Area of a circle, remember, equals pi r squared. So we're actually taking 1/3 times the base area times the height. So however you want to think it. Now, of course, base area means pi r squared. But there's something else that's actually really cool about this, okay? So you remember the volume of a cone, or I'm sorry, the volume of a cylinder. Remember, volume of a cylinder, when we talked about that, that was the base area times the height, right? So if we had a cylinder, and there it is, we would find the area of that and take that times the height, right? So look what we have here. We have almost the exact same thing. We have the base area times the height, but when it comes to a cone, we take it times 1/3. When it came to a cylinder, there was no 1/3 in this formula. So actually, we have kind of the same sort of thing we had with the sand and the pyramid, okay? That is, if you had a cylinder, okay, I'm sorry, it's kind of slanted there, and it had the same base area as a cone, okay, so we'll color that in and call that B for base area, and color that in and call that B for base area, so those would be the same. And it also had the same height, okay, so this has a height as well. If these two heights were the same and these two bases were the same, what you could do is if you filled this cylinder with sand, if you dump it into this, if you fill this cone with sand, if you dump it into the cylinder once, you will have filled it up 1/3 of the way. If you refill it and dump it in there again, you will have filled it up 2/3 of the way, and you guessed it, if you refill this cone, dump it into the cylinder one last time, you will have filled it 3/3 or all of the way. That should have been 2/3 right there. Okay, so the only difference between the formula for finding the volume of a cone and the volume of a cylinder is that a cone is the same exact formula, except we tack on times 1/3, because a cone has 1/3 the volume of a cylinder that has the same base area and the same height. All right? All right, so let's use this, okay? What is this? If you know what this is, I will be very pleased, okay? If you don't, I'm kind of disappointed. But I'm from the Midwest, so, I suppose, I'm kind of biased here. Well, it's a grain silo, right? So it's made for holding all kinds of grain, corn, wheat, you could probably do soybeans, anything like that, okay? And we're going to find the volume of this. So it appears that we have both a cylinder, okay, and so that was that part right there, and then we have a cone, right? Okay, that's what I'm saying. So we're going to find the volume, or hey, how much corn or soybeans can we fit inside this silo? And of course, if you were a farmer, you would want to maximize that because that means you could store more potential profit, right? Store more supply. So how do we do this? Well, we're going to break it up into two parts. We're going to find the volume of this cylinder, and then we're going to find the volume of this cone. Okay, so let's work on the cylinder first. So let's say the cylinder, let's say it's 29 feet tall. 29 feet tall. Let's say the diameter down there, okay, so the diameter of the circular base is, we'll do 18, okay, feet, I'm sorry, 18 feet, 29 feet. So how do we find the volume of the cylinder? Well, remember, volume of a cylinder is equal to the base area times the height. Okay, so what's the base area? Well, we have to find the area of that circle. How do you find the area of the circle? Well, area of a circle is pi r squared. Okay, so pi times, well, what's our radius? Well, the diameter is 18, so the radius is half of that, so it'll be 9 squared. So that's like saying pi times, well, 9 squared is 81. And if you take pi and you multiply it times 81, you will get, rounded to the nearest tenth, you will get 254.5. Now, what are we talking about here? We're talking about area, right? And so our radius was 9 feet. So when we took 9 feet squared, we actually got, and we took 9 feet and we squared it, we now, in the end, get 254.5 feet squared. Okay, so that's our, coming back down here to our formula, that's our base area, 254 feet squared. And now we're taking that times the height. Well, the height was what? 29. Well, that's easy. So 254, should be 254.5, sorry guys, 254.5, 254.5 times 29 will get you 7,380.5. Now keep in mind, this was feet squared, and this was 29 feet, right? So feet squared times feet gets you feet, it's a decimal, feet cubed, right? So the volume of the cylinder is that, okay? So you can fit 7,380.5 cubic feet. What is wrong with me tonight? Cubic feet inside that cylinder. So we're partway there, but we still have to find the volume of that cone on top. Okay, so what was volume of a cone? Well, remember, it was the exact same formula for cylinder, base area times height, but we tack on times a third. Okay, so base area times height times a third. Or you could put the third over there. It doesn't really matter. Okay, so volume of the cone. Well, let's see. We need some dimensions here. Let's say that the height of this cone is 7 feet. Okay, so from the internal height, which would start right about there approximately and go up to there, that's 7 feet. Okay, so let's see. The base area is actually going to be, well, let's see. That circular base up there and that one down there is the same base we used for the cylinder. And we already found that the base area of that cylinder was 254.5 feet squared. 254.5 feet squared, okay? So we're getting there. Times the height, which we said was, hey, right, 7 feet right there. And then we take that times a third. And again, we could have, a third. We could have put the third in front. It doesn't really matter, okay? So 254.5 times 7, that part right there, okay, it's going to get you 1781.5. And we're taking feet squared times feet, should have gone all the way through. And you get feet cubed. But now we're taking that times a third. So I'm just going to leave that in my calculator, 1781.5. And I'm going to say times, parentheses, 1 divided by 3, end parentheses, okay, for a third. And what that ends up getting us in total is 593 point, and I'll round 8 feet cubed. And that, again, was the volume of the cone. So we know the volume of the cone, we know the volume of the cylinder. All we have to do is add those two things up to find the total volume of this grain silo. So when we add the volume of the cylinder to the volume of the cone, we get 7,974.3. And again, we're talking about volume, so it's feet cubed. And that is the entire volume of that grain cylinder, right? So now if we knew maybe what a cubic foot of corn was worth, we could figure out, hey, how much money you actually have sitting in a full grain silo, which as a farmer would be very, very important, because you need to know, hey, how much product do I have? How much money will it get me if I sell it all? And if this grain silo were to burst or catch fire or something, how much profit could I potentially lose? Which that's going to then influence, how much insurance you might have to pay on something that big, because if there was a fire, you would obviously want insurance to cover that because you've lost all your profit. And that's going to determine how much you pay in insurance. So there you go. That's how we kind of use that in maybe not everyday life because you're not a farmer, but a lot of people around the world will use this. You inevitably will at some point need to know how to find the volume of a cylinder or a cone, or it might be very helpful. And that is all I have for you on this video, and I look forward to seeing you guys in class.